Hey, good morning, everybody. Welcome to our Cube webinar about our new DBT integration. I'm going to give folks maybe another minute or two here to file on in, and then we'll get started. Okay, well, yeah, I think people will kind of keep shuffling in here, but yeah, this is a really exciting topic for all of us at Cube. So I think we'll go ahead and get started. And yeah, today our topic is we're really focusing in on our new Cube and DBT integration. Title of the webinar is Trust Your Insights with Cube and DBT. I am filling in for our usual host, Nathan Kitzman, who is in the hospital, and we hope he all gets better quickly. He's should be back with us tomorrow, but yeah, I'm taking over for Nathan, so we all wish him the best. And my name is Brian Bickle. I'm the VP of Alliances here at Cube, and I've got Lewis Baker from Rittman. Lewis, do you want to introduce yourself?
I do indeed. Yeah, so I'm Lewis Baker, Chief of Operations here at Rittman Analytics, and we've been working closely with Cube for actually it must be a number of years now, actually, Brian. And we're super excited to see this new integration with DBT, and excited to see what Igor's going to move on to in a moment with the demonstrations.
Yeah, and I've got Igor with us. So Igor, yeah, go ahead.
Hey everyone, yeah, so I'm the head of DevRel here at Cube and also the one who was trusted to present the DBT integration, the all new DBT integration. I dare to say that we have here at Cube, and I'll be happy not only to show it to you, but also to be getting your feedback on this webinar and moving forward, Slack community and in every channel that you can use to bring your feedback over to the team here at Cube.
Cool. Well, thanks, Igor. Thanks, Lewis. Great to have both of you on today. And yeah, let's go ahead and get started. So let's see what we will discuss today. Yeah, as I mentioned, really we're here to focus on the Cube and DBT integration, but we're going to go through our welcome, a little bit of background about what is Cube if you're not familiar with that. Igor is going to take us through kind of the history of the integrations with DBT, and then really spend a lot of time on like what the new integration looks like and its sort of capabilities and different odds and ends. And then he's going to go through a demo. And then after that, we're going to kind of settle into a little panel discussion about the new offerings and kind of where we see things going. And then we hope that y'all will jump in and ask us any questions that you have along the way. So yeah, I mean, as we're going along, if you have questions about anything we're discussing, drop them in the Q&A, and then we will get to them during the panel. But yeah, go ahead and to move on here. First off, yeah, I'm happy to kind of explain more about Cube. If you're not familiar with us and like what we do, we are a universal semantic layer. And I like to describe Cube as being really focused on helping companies build data-driven applications. And that could be a number of different kinds of data experiences, whether that's building an embedded analytics system from front-end frameworks and kind of like rolling your own interfaces, or whether that's using multiple BI tools and connecting them together and kind of building this consolidated internal analytics use case. And then recently, we've really seen this evolution in people being interested in using semantic layers for providing better data to AI agents so that they can make better decisions or more informed sorts of outputs and maybe grounded in truth a little bit more. And that's really sort of an emerging use case for us that's really interesting. But the big idea behind Cube is making data available to kind of every user in the enterprise in a consistent way. If you're really kind of trying to understand maybe the context from where we come from and like where the product evolved from and our thinking, really you have to look at the last couple of years of data engineering. And increasingly the companies that we deal with have more and more data sources, and consolidating into one cloud data warehouse sort of seems to be a pipe dream at this point. As great as our partners out of Snowflake or a Databricks are, getting all of your data assets into one database is probably not going to happen. And there are an increasing number of maybe point solution databases that have very good characteristics for specific workloads. So you might want to keep them around. So that creates this problem of how do you connect all of those data sources to the expanding number of downstream tools that you have as well. These are the use cases I was just talking about with things like embedded analytics, BI tools, AI agents, and every day as the guy looking after alliances here, I learn about new tools and how our customers are trying to use them, and we think about how to make that integration work. This sort of many-to-many problem is affectionately known as the spaghetti slide internally here at Cube when we present this. And it's sort of the reason we exist is trying to address this issue and trying to solve this problem for our users. If you're interested in sort of orienting, where the semantic layer fits inside the modern data stack, right here, sort of adjacent to whatever your data source is, whether that is a data warehouse, as the box indicates, a lakehouse, some combination of relational databases, or query engines over object store over Parquet, or even exotic time series databases. All of those sort of set right next to Cube and the semantic layer. And we read that data, and then we make it available in sort of a more consistent, more performant way to all of the downstream use cases that we talked about. So, I guess germane to our conversation today, we don't have like a direct, arrow to DBT in this slide, but Igor is really going to talk about what the direct arrow to DBT is. So that reminds me to go update this slide. I'll say it that way. Let's zoom in maybe a little bit more on like what functionality exactly Cube provides to sort of achieve the goals that I talked about. When we think about what Cube Cloud does and semantic layers in general, we think semantic layers include 4 major capabilities. Those are data modeling, access control, caching, and the API endpoints with which data leaves a semantic layer. So Cube provides the data modeling experience in a code-first, easily version-controlled, easily maintained data modeling experience that can either be done in JavaScript or in YAML, and then as we shipped last week, with some really nice Jinja templating extensions and a Python experience. So if you know Cube's history, we are no longer a JavaScript-only product. We've really expanded our developer ecosystem to give the people what they want. I'll say it that way. As far as access control goes inside Cube, if you're going to build a consistent semantic layer for all of your applications to query, to interact with, to get data from, you really need to have strong access control properties. Cube has a role-based access control system that is accessed via security contexts. It handles things like row-level security and column-level security, column masking, all quite easily, and really provides for a multi-tenant experience if you're trying to build a solution where maybe you want to restrict access to certain metrics or filter them based on who's asking the question. Next, to move on to caching, we have a proprietary caching technology that we call Cube Store. It's very good at rollups and aggregations, and this is an optional feature that customers can take advantage of. But even if you don't explicitly set it up, we do have some in-memory caching that can help you out and cache result sets and make queries faster. But if you do take advantage of this, you can design rollups very easily to support your analytical queries and to make sure that we are pre-aggregating data for you when you want, so that we can accelerate any query that you're asking. Finally, data leaves Cube via our APIs, and we offer REST, GraphQL, and SQL API, with SQL being a native Postgres language. The REST and the Graph may be more suitable for application development or kind of building your own interfaces, and where most BI tools will find that SQL API quite useful. As far as, really like getting back to like the why you would even think about implementing a semantic layer, we think about these sorts of issues as far as the benefits. We address data consistency with our data modeling capabilities and with making sure that, the many-to-many BI tools or embedded analytics products that are connecting to data sources, instead of having them connect directly to a data warehouse and maybe maintain metrics or data set definitions inside each BI product, instead centralizing it in a semantic layer helps ensure consistency. Similar to that point with security, we sort of gain the same benefit of centralization by, centralizing through a semantic layer and using the semantic layer as the source of security. So you don't have to define things like group level security or trying to implement like user or row level security schemes inside a specific BI tool, and then finding out that maybe another BI tool doesn't have the same security capabilities. Performance is offered by our caching technology, which can help speed up cloud data warehouses, if you're asking like really repetitive or kind of large queries, and especially can be very beneficial when connecting directly to a relational database that maybe isn't quite suitable as an OLAP source or as a, to support analytical queries. These last 3 points around flexibility, time to value, and future proofing, I like to sort of all group together and say that really by implementing a semantic layer in the middle of your data sources and your downstream tools, you allow for a flexibility of being able to swap any of those tools in or out and maintain a logical data model and a logical sort of interface rather than hard interfaces to each tool. So yeah, I mean, this makes things easier to implement, and it tends to future-proof you if you decide to remove a tool or swap one out later. And with that, I've told you about Cube, so I'd like to pass it over to Igor and let him tell us about the integration with DBT.
Yeah, great. Thank you, Brian. I think that was a really nice intro into what Cube is, what Cube does. I know that we always have a fair part of the audience in our webinars who are very new to Cube, and the other part is the ones who know Cube through and through. And I think just understanding what Cube is as a product and what it's capable of really helps, because I'll just have to explain a little bit less. So let me start with a bit of a historical background on the DBT integration that we had here at Cube, because over the course of the last 2 years, a lot of things happened, and I think this is quite good to understand the historical perspective, to really grasp, why their integration that we'll be talking later in this webinar is really built that way, and why it is, in my opinion, the best way to build the integration between DBT and Cube. So I believe some of you remember this famous issue on their DBT core GitHub repository that was filed on October 15, 2021, and it is still the most commented issue on the DBT core repository, and probably it's really easy to understand why it was commented, because under the name of DBT should know about metrics, an important idea was shared, right? That DBT as a product that is used for data transformation has got to a point where, either you as a data engineer use it for data transformation, or you know that you can do that, and it became kind of this universal thing. So with a lot of questions, with a lot of thinking about how to get from the neatly transformed tables in the data warehouse to the point where all your downstream data consumers like BI tools or data apps get consistent metrics. that was a question in everybody's mind, and well, it was reflected in their discussion under that GitHub issue. As we later learned, well, maybe that issue was some kind of a marketing stunt for the upcoming release of the DBT matrix, right? Which was revealed in the documentation roughly a week after, on October 23rd, 2021. And we were observing what's happening, and we saw that, well, from the interest in the DBT community, as a consequence, some of the DBT users started to actually annotate their models with metrics and just try to use that. So in the following months, we've released their initial, or the first version of the DBT integration with Cube, which was based on those metrics annotations. I wouldn't say that a lot of users in the Cube community actually adopted that. Well, because of many things, but primarily, I guess it was affected by the level of trust and level of adoption of DBT metrics themselves, right? Probably that was a wise decision on the part of those who weren't that eager, weren't that quick to adopt DBT metrics, because just if you fast forward to this year, 2023, we learned that DBT decided to actually deprecate DBT metrics, right? And they even acquired a company called Transform, the creators of Metric Flow, with the goal to use that technology to replace DBT metrics, right? And this is what we currently know as a DBT semantic layer. The main learning point here was that relying on their DBT metrics, or what comes to replace that as the standard for describing the models, the metrics, or in more general language, there calculations that should be performed on top of DBT models, probably is not the best way to integrate because of their of the fluid nature of this. So we got thinking, okay, what would be the best way and the better way to actually build that integration, so it's not dependent on this flaky nature of DBT metrics, and what would be the most robust way, and also what would be the way that all DBT users would benefit from, because again, we probably don't expect DBT metrics or DBT semantic layer to be as widely adopted as the core product that DBT has is, right? So obviously DBT has its niche as a data transformation tool, and that has the most universal adoption. So we've decided to rebuild our integration with the goal of getting the maximum possible adoption, and that means that the integration should be with the DBT core itself. So just about a week ago, we announced the DBT integration with Cube, which we can call it the DBT integration with Cube 2.0, which I'm very eager to reveal to you. But I'd like to mention that the important thing is, and this is what you, Brian, also mentioned. The important thing is that this new integration is based on a couple of other things that we revealed just about a week ago. So as you know, Cube as a semantic layer is a code-first product. We really embrace using their best practices from software engineering in the data world, because we believe this is a way to bring robustness, maintainability to the data world. And that is why the data modeling that is done within Cube is done in code. And right now, we like as of last week, we support Jinja as a template language and Python as a programming language to build your data models and to make sure that that your data model integrate with all kinds of tools. And the DBT integration is probably the first and the best example of that. So. In case you're watching this webinar in front of a huge screen of a home theater, just bear with me because I decided the best way to jump from the historical perspective to the real world of today would be to change the background drastically. So hopefully this is not burning your eyes. So this is the diagram that you already saw. Some of the slides that Brian has shown you, but let me just reiterate that that we believe and we know from the conversations with the Cube users, with the Cube community, that the most common and the most sensible way to use DBT with Cube would be to rely on DBT for data transformation and materialize the models into data warehouse. This is what this arrow is responsible for, and then define your data model on the Cube side on top of those models. This is what this arrow is responsible for. However, you might guess or you might know from your own experience as a DBT and Cube user that doing so would require you to have a little bit of duplication in your code, right? You'll have your DBT models and you also have your data model on the Cube side where you also need to define cubes. As your data model evolves, as you add more DBT models, you'll need to keep your data model in Cube in sync with that. So the integration that we were talking today just simplifies that process and allows you to cleanly segregate their concerns. And if you wonder how, let me proceed to the next slide. So the key ideas behind the integration that we're talking about today are really simple. So first, we think that the best way to interoperate between the products and to integrate them together is to use their manifest JSON that the DBT produces as the standardized interoperable format which contains all necessary metadata about the DBT project. So, well, if you go to the docs that the DBT has, well, it even contains the schema definitions for this manifest JSON file. There are more than 10 versions already, well, this is not something that might change overnight, right? So this is really a stable thing and standardized thing to integrate with. The second idea is that DBT models, or more specifically data marts that you would define on the DBT side, should be reflected on the Cube side as cubes, and every column that a data mart has should be reflected as a dimension. If you can do that, and indeed you can with the integration that we have, then you don't have to do this excessive additional work on kind of defining cubes that match your DBT models, defining dimensions that match columns of those models. And the third idea is that you just let Cube, as a semantic layer, do what it does best, right? To define measures that you'd like to calculate on top of your models, define joins between cubes, and well, if you'd like to, you can also define views as a surface level of your data model. So this might not sound very simple because I just maybe spent 2 minutes talking about that, but it is really that simple. Just take your DBT project regardless of where you run it. Pick the manifest.json file, bring it to Cube, use the integration to map your data marks to cubes, to columns, to dimensions, and then just use Cube as you should. And with that, let me actually show you a demo of the integration and just help you build an understanding of how everything works. So with that, I'll just share my screen. And that should be an entire screen. So hopefully you see the blog post that we published last week on this very integration. And I was happy to be the one to present it to you. So if you'd like to get more details, just feel free to navigate to our blog and give it a read. And also, if the most important part or the most important supplementary materials to this webinar and to the demos that I'm going to show you are the docs. And under the guide section, we have a very elaborate guide on the best practices on using DBT with Cube and then the details of this integration. So please feel free to check that out. And just full disclosure, this DBT integration is powered by the Cube_DBT package, and the docs on that are also available on the Cube's website. So this demo is based on the Shuffle Shop project, the one that you are surely aware of if you're a DBT user. And yeah, actually here in this repository, Shuffle Shop Cube, we have everything under the DBT folder. And this I also have it locally on my machine. So while we're talking, I can just do DBT run. So you'll see that indeed it's parsed, it's analyzed, and it is materialized to the data warehouse. Here's the data warehouse that we use. It's Snowflake right here, and here are the materialized tables like customer service, things like that. I think this is the most unsurprising part of this setup. However, as you most probably know, many commands that you can run, like dbt run or dbt build, they produce manifest.json file under the targets folder. So we can actually inspect it, and here I'm piping it to the GQ utility which would present the JSON contents nicely, and last, just so we can explore the file from the very beginning of it. So yeah, if we preview the file, we'll just see that it contains all the metadata for the DBT project, and well, here you can see that it's a relatively fresh file. We've just created it, and yeah, I'm in GMT +2 time zone, so this actually makes sense. And if I scroll down, you'll see that we've got every model materialized here. So yeah, this is a staging model for locations. And if I keep scrolling, I should find some more model definitions, also definitions for tests and all the rest. So this is a file that the integration we're talking about would work with, and you can feel free to make it available to Cube Cloud in any way that works for you. For this demo, I've decided to put this file over to AWS S3 bucket. Here is manifest.json. I think I can just do it right now if you wish. Once again, yeah, I'll just grant public access for the ease of doing this demo. But again, you might be using some automation around your DBT project. This might be DBT Cloud. This might be some other tools which gain popularity in the data community. So yeah, there are many ways to actually build and run your DBT project and get your manifest.json file refreshed. So finally, we get to Kube Cloud, where I just run a deployment that is connected to the same data warehouse. And let's start by reviewing the new parts of the data model, or relevant parts of the data model here. And by new, I mean that this is something that we've just introduced about a week ago with this Python and Jinja update. So you can see there are like a couple of files in the requirements.txt file. We've got the kubedbt package, which powers this integration. We've got the kubepy file, which is a way to provide settings to Kube, and it just says, hey, our data model is under the model folder, which is kind of obvious, but anyway. And here we get to the globals.py file under the data model folder. In this file, we provide the global template context for all the Jinja templates or YAML files that we have under the model folder. So this is really something that would produce the template context that we in turn can use in our data model files. So I think not a lot of things are happening here, right? So we import the kubedbt package. We put the URL of our manifest.json file in a variable, and if I click, you can see that, well, it's actually reachable from here. And yeah, the only last thing that we need to do is to instantiate an instance of the DBT class. We do it through the static method from URL that loads it from, well, unsurprisingly loads from URL. What you can also do, you can just access the contents of manifest.json in any way that suits you. For example, you can use the smart open package to load it from the password protected AWS S3 bucket, or just from any remote storage. You can also download it via an API, and if you did so, then you can just instantiate the DBT class with your manifest contents as a dictionary. But we have it available under this URL, so we're just using this static method. And there's also an interesting thing happening here. So we are filtering the models by their paths, right? So let me actually switch to this folder and just show you the layout if it's something that's not very clear. So, but under models, we have our staging models and we have our data marts. Well, as I already said, it makes sense to map your data marts as a final layer of your transform tables to cubes, and it doesn't make sense to do so for the staging models. So most probably in production setting, you would just say, hey, let's pick everything on the marts, and this is exactly what is done with this command. However, you have more options here. So another thing you can do, you can just say tags, and then you can just provide a list of tags for just a single tag that your model should have to be surfaced to Kube. Or alternatively, if you're just getting started, you can just say, hey, I just want to just want to load a specific DBT model, and that is also possible. However, we'll just go with loading everything on the marks. And this is all. So the rest here is just the bits of syntax to expose their DBT models to their YAML files where we defined our data models. So you can see here that we've got a couple of functions. One is called DBT models, and apparently it just exposes all loaded and filtered models. And the other one is called DBT model, which allows you to access a DBT model by its name. So in this toy example, and we have this file called all.yaml, where we indeed just iterate over all models, and we render every model as the cube. So this method basically translates the metadata of models from the manifest.json file into the relevant fields of the cube definition, right? So your title, the DBT side, the name on the DBT side becomes title here or name here. The description is mapped to description, and the relation to which your DBT model is materialized becomes the SQL table definition here on the cube side. But enough talking. So with this very simplistic data model, we should be able to actually see that Cube has created a cube for every DBT model that we have on the marks. Indeed, we have customers, owners, products, locations, etc. And we can even go to the playground and query those cubes. So if we go to customers, I can query the count measure, and it works. Yeah. And if we navigate to the generated SQL tab, we'll see that indeed the relation under which the customer's model is materialized is correctly picked and put here, right? So it's under Cube Dev and Jekyll Shop database and schema in Snowflake. But well, I would say that this is quite well useless in this setting because well we don't have our columns, we don't have anything in our data model, right? So I would argue that in a production setting, you would probably not do something like that, but you would do something which is more suitable for production. So instead of iterating over the DBT models and just creating the definitions in a single file, you will probably go with the approach where you have one file per every cube and consequently per every DBT model that you have, and this is exactly what's currently shown on screen. So I've got a couple of cubes here. The first one is called customers, and we just read it as the DBT model right here, and then we render it in the data model here as a cube, which has all the dimensions translated from their columns in our manifest.json. And here under orders, we have basically the same pattern. We materialize the cube, and every column becomes a dimension. And the only interesting thing here is that we're also defining a join between orders and customers. And as you can see, I think this is really nice detail here. As you can see, we are referencing the customer ID dimension in here, but neither this nor this file has this dimension defined explicitly. So it's just going to be rendered based on the metadata from the manifest.json. So if I click show graph right now, we'll see that our data graph consists of couple of cubes which indeed are joined together. And if we navigate to playground, we'll see that every column has translated to a dimension in the cube side, and we can build a query, and it would work exactly as I think it should. And if you navigate to generated JSON, we'll see that correct column names are also used. And yeah, so this is probably the most time-saving. I just want to say life-saving, but it's just time-saving moment. So when you have your models annotated on the DBT side and with descriptions and with columns, and they'll be annotated with descriptions as well. This is all you need to just bring those to cube as cubes with dimensions, and then the only thing that you need is to spend some time to define the measures that work for your domain. Yeah, and obviously, kidding here just producing something that probably doesn't make sense in any domain. But this is just an example that with this integration, you can split you can segregate the concerns and just focus on creating normalized data marks on the DBT side and creating your semantic layer on the cube side. So if I go to customers over here, I should be able to see this new measure as well. And indeed of course, yeah, and indeed it doesn't work because this should be a count star query, right? So if I navigate to the playground right now, this indeed should be a query that we can run. It worked indeed. Okay, so yeah, this is how it looks like. So whether you have something really similar to the Jaffle Shop project, or whether you have something more detailed with dozens or hundreds or thousands of models, just feel free to have your YAML definitions. Feel free to mark the columns with the primary key tag. If this is indeed a primary key, feel free to mark your time columns with appropriate data type. And these literally few lines of code on the cube side is everything that you need to integrate your semantic layer that you built with cube with your data transformation layer that you built with DBT. And with this, I think this demo is over.
Thanks, Igor. I appreciate you going through that, and I'm sure it was informative for the audience to kind of get a sense for what we built and our thinking behind it and how it works.
I'm actually disappointed because I see only a couple of questions on the Q&A tab. So folks, if this sparked your interest and attention, please feel free to just ask the questions. This is what we really eager to see and hear.
Yeah, so that's a good segue. I'd like to go ahead and kind of move on to our discussion, and then as Igor mentioned, if you have any questions or you have any comments about what was demoed or any of the content so far, please get them in the Q&A, and we'll sort of weave them in here with our chat with Lewis from the Ritman Analytics team. But yeah, I'd like to go ahead and maybe call on him here a little bit and ask some of this. Some questions to Lewis. Lewis, we demoed this to the team over at Ritman maybe like a week and a half ago, just trying to get some of your thoughts on it and to understand how you guys think about this problem. And one of the things that the Cube is really interested in building towards is like this idea of like open standards and cross-platform interoperability. And I know that, in the pre-call, we sort of had a chat about this, and I was just curious to kind of get some of your guys' thoughts about this and maybe how the way that Cube has architected this sort of plays into that narrative and like what that does for Rittman as a consulting firm.
Yeah, great question, Brian. So, I think that we sort of caught wind of this happening around about 2 weeks ago now, actually, and it was heavily welcomed. And this is such an integral feature. Actually, 2 years ago, we tried to build out our own open source solution for this internally, where we tried to couple the content that's generated through DBT and the information schema of a warehouse, and then bring that through intuitively and programmatically into Cube. So when we heard that this Cube was doing this, it made complete sense. And there's really three main reasons for that. One is that piece there that Brian's discussing, which is the thing about interoperability, the linking together of tools. And one of the things that the modern data stack does is where it takes apart the monolithic tools that you would have been using with Oracle or IBM, that are now sort of like falling out of use, especially with the smaller and mid-sized companies. That breaking apart of the monoliths can introduce engineering overhead, because you then need to find a way for these tools that are now disparate to communicate together easily. And it's this sort of solution that decreases the friction between those tools, and it's heavily welcomed for that reason. That's one thing that I thought about upon initial reaction. The second piece is cycle times, and one of the issues that poor communication between tooling introduces is slower cycle times. And what that means is that it takes longer for end users to get sight of the data, and the longer it takes them to get sight of the data, the greater the chance of there being poor data quality is, or that feature you built out not being fit for purpose. So by decreasing the friction between tooling here, it's increasing the speed at which you can get that first cut of the data out to the end user so that they can QA it. And that decreases the risk of it not hitting the mark or being incorrect. So this is definitely a step in the right direction of helping decreasing the amount of overhead that engineering teams have and increasing their cycle times. And that's something that we've been thinking about a lot recently internally. And the third piece that I'd like to open up for discussion is overhead in data apps. So if you're thinking about, as a company, going towards like a data mesh or data fabric architecture, every single step that you have to do manually then has to be replicated across those different services. And if that's done manually, for example, if you're building out a model in DBT and you need to bring that through into Cube and you need to handwrite all of that content, that has to be done across all of those different services and many times if you're looking at doing anything other than a monorepo. And it's these sort of tools that really enable, these top sort of features that really enable that data mesh or microservice approach within your data architecture. So yeah, we were super excited when we saw this being released because it solves a lot of those problems, and it also meant for us that Cube get the problems that people are experiencing in the modern data stack, and they have answers to it. So yeah, it was great news when it came forward, and we've been playing around with it internally and already got some really interesting results. So Brian, with those sort of talking points surfaced, the piece around interoperability, piece around microservices and data mesh, and that becoming feasible with tooling like Cube, as well as getting stuff out the door quickly so that you're not waiting months to get data in front of end users. Did you, when you were building out this functionality, were those issues front of mind? And is my interpretation of why you've done this accurate?
Yeah, Lewis, I'll give my take on it. I've been at Cube for a little over a year now. I'm not on the developer or engineering team, but I work very closely because of the nature of ecosystems. The way I see Cube's role in all of this is as a universal semantic layer, and that's what we say we do, and that's kind of what we aspire to. We, right there in the name, are interested in tool interoperability and open standards and ability to give developers really the choice to bring whatever tools they want in their stack. And I think a lot of the design paradigms inside Cube really, I guess, understand that developers can be empowered with these choices, and we want to give them that flexibility to make choices rather than being, I think, overly prescriptive about like a small handful of tools that we play best with. And so I think that definitely speaks to interoperability. I might ask Igor, for his comments on this, because I know he was pretty heavily involved with the development of this package and sort of the thought process behind it.
Yeah, sure. Sorry if this is maybe too generic, but my general stance is that, well, Cube as a semantic layer is just uniquely suited to be the one. Well, I wouldn't say sitting in the center of the data pipeline, but to be the one that integrates with the most of the other tools that we have. Not only the upstream and downstream tools, like namely data warehouses and BI tools and data apps, but also with the rest of the stack that you have. Because of course, we've just reviewed the case for data transformation to integration, but that is not all. So I can certainly see kind of reverse ETL products like working with Cube. I can certainly see data quality tools also integrating and working with Cube. So indeed, Cube is uniquely positioned for that, and I believe that the best thing we can do is just to make sure that every sensible integration, every sensible connection with the other tool just works. And this webinar and the whole integration is just a small step towards that goal.
Yeah.
I think that makes sense, and from what I kind of understand about our positioning and where we're going, it's something that I philosophically agree with. I noticed, we since we started chatting here, we do actually have a lot of questions coming in via the QA. So I think, given we've got 7 minutes left, maybe we'll start addressing some of these and taking these on. Someone from the audience asks if we can sync the measures or metrics from the new DBT semantic layer package to Cube. And I'm going to give my answer, then I'll maybe let Igor provide his commentary. But I think the answer right now is that no, you can't do that kind of intentionally in our design. And the way that we think about it is there being a true sort of separation of concerns between DBT as a transformation tool and then as Cube as a semantic layer. And by doing that, we sort of allow for like this really easy interoperability with DBT core, which was important to us, kind of given the traction of core versus DBT cloud in the enterprise. Yeah,
I think this covers it all, right? So if you'd like to get the best of Cube, just use Cube's data modeling capabilities, but also in turn feel free to base your data model on their DBT models that you have upstream. Okay, and I just wonder, Brian, if you'd like to take another question. So Sergey asks whether one needs to have a Cube Cloud account to use the Cube semantic layer, or is it possible to use the open source version of Cube to get the semantic layer capabilities?
That's actually a great question. My understanding is there's nothing in what we just showed that you couldn't do with Cube open source versus Cube Cloud. A lot of what Igor kind of demoed back and forth, I think, is all, for the most part, in open source. There are lots of different functionalities inside Cube Cloud as kind of added benefits, and those are some of the things around, the improved query history. Obviously, you get our own hosting of it, and then when you're considering the BI integration, We have some really great features that we call semantic layer sync that make that quite a bit easier. But kind of in the core connectivity for transformations, like I think you're all good with the open source if you want to go that way.
Yeah, and I would just add that, well, this might sound obvious, but obviously, yeah, okay, obviously, the most part of Cube users, they are indeed open source users who self-host Cube. We invite everyone to try KubeCloud because indeed it provides managed resources and a really neat workspace that I had pleasure to kind of also demo to you in this webinar, but this is not a hard requirement, right? So yeah, feel free to self-host Cube, but if you'd like to use the managed resources and the tools like the query history, playground, data graph, and other tools that KubeCloud has, well, feel free to give it a try because indeed there is a free trial in there, so it's free to try.
Yeah, we did have a similar question. I think we've covered this. Somebody does point out, that DBT makes metric flow available only in their cloud version, which is the paid offering. And I think this kind of ties back to what Igor's saying here, that with our offering here, you can use it with the open source if that's what you want to do by combining that with DBT core and then having a complete open source stack.
Yeah, I see the question about their repository layout. So the question is whether it makes sense to put the DBT project and Cube project in a single repository and use it like that. And I would say that you can feel free to do that. So so there's no restrictions or limitations on the Cube side. So you saw in the Jaffa Shop Cube repository that I've been demoing that this is exactly the layout that we use. And if, for example, you use KubeCloud to run your project, you can just specify the folder under which the Cube data model and configuration reside. So yeah, no limitations on the Cube side. I know that some tools, like for example, Daxter Cloud, have hard requirement for the DBT project to be in the root folder of your repository, but this is something out of my I would say our control, right? So if other tools limit you in doing such things, well, this is unfortunate. However, while you like kind of from the Cube standpoint, should definitely feel free to do that. And also, I think that having both tools with their code in a single repository gives you the benefit of making branches and pull requests that would contain kind of coherent, sensible changes that kind of in a single change set you may have the updates to your DBT models and the relevant updates to their cubes and views that you have on the cube side. So it makes a lot of sense to do so. Great question.
Yeah, just to add to that one, like we've experimented with both options, and if you end up decoupling them too heavily, you can have, if there's a change to the warehouse, you always need to reflect that in Cube, or otherwise, obviously, if the target warehouse entity isn't there or object, you'll run into an issue where it won't compile in Cube, or you'll just get a SQL error. So keeping them together, we've often found is more effective because one PR addresses both the warehouse layer or transformation layer and the semantic, and then you don't get the decoupling of the two or a delta emerging there.
We had a couple eagle-eyed viewers notice Igor's VS Code web feature in there. So yeah, Igor, do you want to tell us about VS Code?
Sure. I'm really happy that that indeed what I was demoing found some eyes at this webinar. Yeah, so yeah, probably it pays off to be demoing from the account that it's kind of on the bleeding edge of the Cube Cloud and what we're developing here at Cube. So there is nothing generally available that I can present to you today, but indeed we are working on the VS Code extension and also the enhanced authoring or editing capabilities for to kind of make sure you have the best data modeling experience in KubeCloud. So yeah, I think we'll be revealing some bits on that really soon. So stay tuned. This should be, yeah, this should be coming.
Well, I can't help but notice that we're at the top of the hour, and I really didn't know if we had a whole hour of content, but it seems like we could have gone longer with this one. Yeah, so I'd like to thank everybody for coming by and spending your morning, afternoon, evening, wherever you are with us. One last thing I'd like to point out: next week, the Cube team will be in San Diego at Coalesce. So we do have a booth. We have a stage talk from our CEO, Artyom Kaidanov, about open standards and semantic layers. If you're interested in semantic layers in general, I would really encourage you to come by for that talk. If you want to know more about the connectivity to DBT, I'll be there. Lots of members from the team will. We'd love to connect with you and talk about data in general. So yeah, that's kind of all I've got. And if you want some more resources, I'd like to maybe share this before we wrap up. There's Igor's original blog introducing this. We've added DBT, a new guide to the docs. Of course, you can always sign up for a Cube Cloud account. Those are completely free to get started. We'd love for you to check us out and take the integration for a spin and give us some feedback. And yeah, I'd really like to thank Lewis from Ritman Analytics for coming by. And you can find those guys over at ritmananalytics.com. They're one of my favorite consulting firms to work with. Been really great partners of Cube. So again, yeah, thanks for coming out.
Yeah, pleasure. And we'll be there at Coalesce as well. So no doubt we'll be around the Cube stand. So if anyone has any questions or needs any assistance, feel free to reach out.
Cool. All right. Well, hey, yeah, thanks everybody. Yeah, you all have a good one. Cheers.
Cheers.